So there are three parts that make up the architect of a basic neural network. These are units or neurons, connections, weights, parameters, and biases. So all these things are what you need to construct the bare bones structure of a neural network. So you can almost think of these as the building blocks of a building. Depending on how you want to build to function, you will arrange the bricks and vice versa. So the cement in a building can almost be thought of as the weights. No matter how strong your weights are, if you don't have enough good amount of bricks for the problem at the hand, the building will just crumble to the ground. However, you can get just the building to function with minimal accuracy by using the least amount of bricks, and then build upon the architecture to solve the problem. What about units? These are functions which contain weight and biases and then wait for the data. After the data arrives, they perform some computations and then use an activation function to restrict the data to a range. Think of these units as a box containing the weights and the biases. The box is open from two ends. One end receives data, the other end outputs the modified data. The data then starts to come into the box. The box then multiplies the weights with the data and then adds a bias to the multiplied data. This is a single unit which can also be thought of as a function. Imagine having multiple of these. Now you will be computing multiple outputs for the same data point or input, and then these outputs then get sent to other units, another unit as well, which computes the final output of the neural network. So what about weights or parameters or connections? So these are the most important part of a neural network, and are numbers the neural network has to learn in order to generalize to a problem. So biases are numbers that represent what the neural network thinks it should add after multiplying the weights with the data. Of course, these are always wrong, but the neural network then learns the optimal biases as well. Hyperparameters are values which you have to manually set. If you think of a neural network as a machine, the knobs that change the behavior of the machine would be the hyperparameters of the neural network. Activation functions are also known as mapping functions. They take some input on the x-axis and output a value in a restricted range mostly. They are used to convert large outputs from the units into a smaller one, most of the times, and then promote non-linearity in your neural network. Your choice of an activation function can actually improve or stop the performance of your neural network. So layers are what helps the neural network gain complexity in a problem. Increasing the layers can increase the non-linearity of the output. Each layer contains some amount of units. The amount in most cases is entirely up to the maker. However, having too many layers for a simple task can unnecessarily increase its complexity and in most cases decrease its accuracy. So there are two layers which every neural network has. These are the input and the output layers. Any layer in between those is called a hidden layer. The neural network in the picture contains an input layer with 8 units, an output layer with 4 units, and 3 hidden layers with each containing 9 units. A neural network 2 or more hidden layers with each layer containing a large amount of units is called a deep neural network, which has actually gone to a new field of learning called deep learning. Neural nets are being used almost everywhere where there's a need of something to solve a problem. So obviously, neural networks are going to be used increasingly in the future, and they have a lot of potential and application, and the backbone of almost any large machine learning project starts with a neural network.